Hello, everyone, and welcome to Modernize Your VM Strategy from On-Premises to the Cloud. Today's webinar is sponsored by Portworx and Red Hat and produced by Actual Tech Media. My name is Keith Ward. I'm with Actual Tech Media, and I'm excited to be your moderator for this special event today. Before we get to this great content, though, I do need to cover some housekeeping items. First off, we want your questions. Put them in the questions box in your webinar control panel. That Q&A panel is also the place to let us know about any technical issues you might be experiencing. If that happens, if you can't hear something or see something, give your browser a refresh or two. If that still doesn't work, let us know, and we will get right on it and try to provide further technical assistance. Next, check out the handout section of your webinar control panel, which is right next to that questions tab. There you will find some great resources, including a link to getting started with Portworx and Red Hat. You will also see links to the ATM Decisions Group, which is a panel of IT decision makers that you can apply to join to participate in some more in-depth events and other opportunities. There you will also find a link to the ATM Events Center, which has our calendar of upcoming events like this one. And finally, we got a prize for you today. At the end of this webinar, we'll be awarding $250 Amazon gift card to one lucky registrant. You must be in attendance during the entire event to qualify for that prize. The official terms and conditions of the prize drawing can be found in the handout section. That is good reading if you're really bored and have nothing else to do. All right. And with that, folks, why don't we get this show on the road here? It is my true pleasure to introduce you to our presenters today. Bhavin Shah, Senior Technical Marketing Manager with Portworx, and Mayur Shetty, Global Solutions Architect with Red Hat. Bhavin, the floor is yours.
As you mentioned, the topic for today is how we modernize VM strategy from on-premises to the cloud. So to talk about that, first of all, we'll start by talking about the need for modern virtualization. Like why can't we just use what we have today? And then we will focus on different products and technologies that will help you modernize your infrastructure stack and deliver on those promises that we might end up making during this webinar. So we'll have Mayur talk about what is OpenShift virtualization, why you need something like OpenShift virtualization in your infrastructure stack. We'll also talk about the cloud component with the Red Hat OpenShift service on AWS. And then finally, we'll talk about like how Portworx can help. And as part of this webinar, we also have a couple of recorded demonstrations that we'll walk through that talk about some of those use cases that we'll discuss throughout this webinar. And then, as Cody, you said, right, like at the end, we'll open it up for some Q&A. So attendees, feel free to add questions in the Q&A panel, as Cody mentioned, and then we can also turn it down for like live Q&A at the end. But yeah, that's a quick agenda for today. Hopefully that's something you liked if you joined us live. But let's dive into the challenge with traditional virtualization. So to understand why we need a modern virtualization stack, we need to focus on some of the challenges that are associated with the way traditional infrastructure or traditional virtualization works today, and then the features that it brings to developers inside your organizations. I think the thing that we can all agree on is like if you are part of an IT team or a platform team inside your organization, one of your top priorities, if not the top most, might be to make sure you're making your developers or keeping your developers as productive as they can be. I know the developers are the new kingmakers. I think that has been around for a while, but as IT teams, it becomes our responsibility to make sure that developers are not waiting around for infrastructure resources. We are enabling self-service for them, and then we're supporting their applications in every way we can. So talking about traditional virtualization, right? I've seen a couple of different kinds of architectures. One where administrators, traditional VMware or virtualization administrators have configured like role-based access control and given developers access to a vCenter interface where they can deploy their own virtual machines. and they have like an internal wiki somewhere where they have listed like what should you select as your network, what should you select as your storage resource or your data store, and then basically have screenshots that they can follow to deploy virtual machines. That's definitely one way to do self-service, because at the end of the day, developers are deploying virtual machines on their own. And then the second way I've seen is like organizations are building custom UIs or custom shims in front of their virtualization stack or their infrastructure orchestration stack, where developers can log in, maybe select from a few drop-down boxes what their request is, and then the IT team or the platform team has some sort of automation on the back end where they're deploying these virtual machine resources that are being requested by developers. So in both of these strategies, right, it's not the best experience. So in the first scenario, even though it is quote unquote self-service, developers still have to learn how vCenter works or what are the different options. They're still following instructions. It's not as simple as, oh, maybe they issue a simple command from their laptop and it gives them access to a specific resource. They still have to like maybe log into a VPN, access the vCenter interface, deploy the virtual machine on specific and configure it for specific settings. So it's not as seamless as it can be with the solution that we'll be talking about today. And then in the second scenario, like the operations teams is still responsible for not just maintaining the UI component, but also all the underlying automation, right? So it's all custom automation that maybe you're building through Ansible or Chef or Puppet or Terraform, any of these infrastructure as code tools to enable this self-service capability. So that adds overhead to your team, right? So it is taking time away from the operations team and making them spend it more on managing the infrastructure stacks instead of helping applications team innovate and deliver better value for their end customers. So that's one of the reasons, like, this is not true self-service. We need a modern solution that has that true self-service developer experience built inside the infrastructure stack itself. Second, let's talk about modern apps and distributed databases, right? I know the topic for today is virtual machines, but back of the mind, every organization or every developer wants to think about containers, or think about not just containers as a mean for deploying things, but even if they want to use virtual machines for deploying, they're thinking about their application architecture, and they're thinking about how they can maybe break down their monolithic application stack into microservices so they can iterate on all of those components quicker. They're thinking about how they can leverage some of these modern distributed databases like a Cassandra cluster, or use streaming or messaging services like Kafka or RabbitMQ, and get access to all of these different kinds of resources on demand. In the first way that we spoke about, just by deploying virtual machines, there's still a lot of heavy lifting needed to deploy or configure these additional databases or modern application components once you get access to VMs. That's obviously, again, not the most seamless path, right? So we want to make sure that we provide a way with which all of these things can be automated as well. And finally, inside your organization, if you're not already multi-cloud or hybrid cloud, definitely you're looking, or you have that on your roadmap. You might be tied down to your infrastructure stack inside your own on-prem data center, but you know on the back of your mind that there is a cloud strategy somewhere, and you need to be ready for that, right? So you need an architecture that can support a multi-cloud or a hybrid cloud infrastructure stack and can provide that seamless capabilities. It can be anything from migrating your applications back and forth to leverage the elasticity that a public cloud solution brings, to portability and making sure if you don't want to run your production apps in the cloud, maybe leveraging that as your secondary site for a disaster recovery solution. So all of these things and challenges contribute to now organizations being in a place where they are looking at what's next. How can I improve this, right? How can I not just improve my developer experience, but how can I also reduce the amount of operational complexity that I have to manage personally, and deliver a solution or build a solution that will help us move on to the next phase of our journey. So this is where we talk about the different infrastructure silos that have eventually being deployed inside our data centers, right? So if you're running a legacy or traditional virtualization stacks, you will have either bare metal nodes running virtualization. You might have a converged infrastructure or a hyperconverged infrastructure stack with dedicated compute nodes, dedicated storage arrays, a virtualization layer, and you're deploying virtual machines with their own guest operating system. That was the way to do things for a while. for a couple of decades. Then we started deploying containers and Kubernetes, and the most easy way to do this was, let's just deploy Kubernetes on top of virtual machines, because we already know how to deploy VMs at scale and manage them at scale. So maybe that gave us like an easy way in. That became a second solution, like, okay, I can now start using containers, but I'm still running those containers on virtual machines and my traditional infrastructure stack. After that, again, you can be at any of these stacks, right, in your own journey. The third stack that we have seen is people eventually feeling comfortable of running Kubernetes and running their containers directly on bare metal servers or bare metal nodes inside your own data center. So the point that we are trying to convey is, in any major or any big organization, you will have a mixture or a mix of all three, if not like at least two, if not all three stacks that you are running today, with maybe dedicated teams or silos that are responsible for managing that infrastructure. What we are trying to talk to you about today is how you can modernize, right, and break down those silos and build a solution stack that can help you run not just your containers, if that's what you want to do as your long-term strategy, but also run your virtual machines on a modern infrastructure stack that can give you some of the benefits associated with the 12-factor apps methodology, or even some of the newer principles like GitOps and CI/CD. So let's talk about like why you should run virtual machines on OpenShift. The first one being it's an easy lift and shift migration, right? So you don't have to take on the strenuous task of modernizing or breaking down your monolith, or refactoring your entire application and rewriting everything as containers. You can take your applications that are running on virtual machines today, and then you can move them as virtual machine objects, and not just bloated containers, and run it on the new stack. So you can migrate easily using tools that are available from Red Hat, and we'll talk about that more in the next few slides. And then eventually, right, once you have migrated everything over to this new stack or new way of doing things, you can then decide, like, okay, this is an application that we want to add more features to. What's the best way to do it, right? Let's go ahead and refactor that app slowly. Start by maybe modernizing the front end components. So instead of running like HA proxy on a virtual machine, or running Nginx server on a virtual machine, how can you containerize that? Maybe 6 months down the line, you figure out how to containerize and run data on Kubernetes, which is where Portworx shines as well. And so eventually modernizing your entire application stack. So by using such a solution, by using OpenShift and Portworx together, we give you the flexibility to modernize at your own pace, rather than having to have a 6-month project where maybe you're hiring a lot of consultants and modernizing all your apps that you didn't need to, just to move to the new stack. That's not what we are here to sell you today. We're here to talk about how you can use existing applications running on VMs, migrate it to a new infrastructure stack, and then as you want, you can modernize things if that becomes your organizational priority. The benefits that you get because of this is you get that unified management layer, right? So you get one single way of doing things, or deploying your applications, deploying your containers, deploying your virtual machine objects on the same infrastructure stack. So you no longer have to have like 3 different teams, experts in managing different storage arrays or different compute layers. You have one way of doing things, one way of managing infrastructure stacks. And as you will learn throughout this webinar, right, how you can take this infrastructure stack that you have built on-prem and replicate it in the public cloud, so that if you decide to choose or build that multi-cloud or hybrid cloud architecture, you can do that using this new modern infrastructure stack as well. I know usually in webinars you get the business benefits at the very end, but I wanted to like front load this and talk about some real benefits that you will see if you think about or choose this modern solution. Just comparing with publicly available data, if you look at the cost reductions from a traditional virtualization solution to a modern virtualization solution, a medium cluster, right? Like not, you don't see $1 million in savings if you are, we're not saying that you will see that only if you're running more than 10,000 nodes. No, this is like a realistic number of nodes. If you choose to migrate over or move over to this new modern stack, you save more than $1 million in over a 3-year period. And we have some TCO numbers. If you are interested in learning more, feel free to reach out to us. In terms of storage savings, definitely because of the way Portworx and Pure Storage work together, we can offer those. Portworx is that #1 Kubernetes data platform, and we'll have We'll talk about why that is, but we can offer you a storage savings percentage of 60%. And then because of the modern way of doing things, enabling that true self-service capabilities, following modern principles like GitOps, you can reduce the amount of time it takes to provision your virtual machines down to a matter of minutes instead of days if you have to involve your network admin and your storage admin and your virtualization admin, and everyone has to work together. So those are just some of the benefits you will get when you think about modern infrastructure stacks. But instead of just talking about it from a higher level perspective and talking about some of the benefits, let me bring on Mayur to talk about OpenShift virtualization, what it is and why you need something like that. So Mayur, I'll hand it off over to you.
Thanks, Bhavin. So let's look at the next couple of slides as to what OpenShift virtualization really is. So before we look into what OpenShift virtualization is, let's quickly touch on what OpenShift is. So Red Hat OpenShift is basically a hybrid cloud application platform. And it's under the hood, it's powered by Kubernetes. So what this means is Red Hat has taken Kubernetes and we made it ready for enterprise to be able to use it in a production setting. So if you look at any production Kubernetes cluster, it has a lot of other services and tools besides Kubernetes that makes it really production ready. So what we've done is we've taken all of them, all those tools and services, we've tested them, we've hardened them, and we've bundled them as OpenShift, and hence making it a truly turnkey platform. So now I said it's also hybrid, and the reason it's hybrid is it's because it can run on any platform. What I mean by that is it can run on premises, on bare metals. It could be on a private cluster like OpenStack or virtualization platforms. It could be running on Red Hat virtualization or VMware for that matter, but also on the public cloud. It could be on any of their popular hyperscalers. And nowadays, we've also seen customers running OpenShift on edge devices like a 3-node server or a single node server. That's becoming pretty popular these days because of IoT and AI kind of workloads. So I said that we've bundled a lot of features into OpenShift, and some of the features that we've added to make it truly turnkey, it's like Kibana. Any production cluster would require Kibana to look at your log data. And we've added, and that data is collected by Fluentd and it's indexed by Elasticsearch for you. One of the things that you would require is for your services is container images, and you need a place to save that. So what we've added is we've added a local registry to your OpenShift cluster. So that way, all your container images can be local on the cluster that you're running. So one of the questions that we get quite often is, how do I monitor the health of my system? And for that, we have Prometheus for monitoring not just the systems, but also the services that you are running on your OpenShift cluster. And we have Grafana for analyzing and visualizing the metrics. So in addition to all that, we've also added a lot of admin and developer tools, CI/CD pipelines, IDEs. All these are part of OpenShift. And when you deploy OpenShift, it comes with that for you, making it truly turnkey. And now back to OpenShift virtualization, that's just one feature of OpenShift Container Platform. And I'll touch on that a little bit more on the upcoming slides. Next slide, please. So containers and virtual machines are basically technologies that make applications independent of the infrastructure resource, right? And they both do it in a very different way. Containers do it with process isolation. And what they do is they leverage the kernel namespace, and it provides process isolation. And it also leverages another Linux feature called cgroups, which provides resource controls. So if you basically, at the end of the day, containers are nothing but it's a software code package, and it contains your application code. It contains the libraries that your application depends on, or any other dependencies for that matter. Virtual machines, on the other hand, they do it in a very different way. They are basically a digital copy of your physical machine. You can have multiple virtual machines with individual operating systems running on the same host operating system. And the way virtual machines is they rely on the hypervisor, and that's the key difference between virtual machines and containers. And I just wanted to touch on this before we went a little bit deeper onto OpenShift virtualization. Next slide, please. So, of course, not every application can reside in a container. Just as many legacy applications do not support the cloud or have limitations on how and where they can be deployed, there are some applications which have hard dependency on the VM, on a virtual machine, and the structure of the virtual machine. And the number of reasons for that, why these applications are not good candidates to be containerized, or Bhavan has touched on some of them. And I just wanted to add a couple of more to that list is we've seen customers who have applications which rely on the operating system, which has been EOL'd, or it's an older version of the operating system. And they need to take those, which is containerized as is, into a more modern platform like Kubernetes and OpenShift. And for those reasons, OpenShift virtualization comes into play, and you can take your containers and your virtual machines and have them in a much more modern platform where you can run your services and applications together. Next slide, please. Now let's look into what OpenShift virtualization is and what it allows you to do. So basically, it allows IT teams to run virtual machines alongside containers. And the way it's done is your virtual machine is within a pod on the same cluster. And how it helps you is it allows you to simplify your management and it improves your production time. Just like how your containers were benefiting from all the services that were part of OpenShift, now your virtual machines can benefit from all those services and be treated as a first-class modern citizen. So the main thing is the containerized workflows, right? Previously, if you had brought a VM and the VM was outside the Kubernetes cluster, they would be treated as a second-class citizen. It would not be benefiting from all the workflows or containerized workflows and the existing investment on the CI/CD pipelines, the tools that you have put in place. But now, because it's a first-class citizen, because it's part of Kubernetes, it can leverage all the benefits and all the services that you have put in place, and your existing investment in virtualization still holds good in a modern platform. Bhavan, next slide, please. So let's look into why customers are looking into OpenShift virtualization. First and foremost, we've seen it allows you customers to jumpstart into their modernization strategy. Now, because OpenShift offers a single platform for managing both VMs and containers, like I said, it reduces complexity. It's as straightforward as that. And it allows you to have a single infrastructure platform for managing both your containers as well as your virtual machines. Not just an infrastructure platform, but also the management tools. And this improves efficiency. We've seen customers telling us that the productivity has gone up just because their VMs and containers are now in the same platform. And again, it increases the overall efficiency of the system itself, because now we have a single team which manages not just your containers but also your virtual machines. All this reduces your cost and also increases your time to take your services to your end customers. Next slide, please. So let's look into what OpenShift virtualization does. So OpenShift virtualization is basically an operator which is included in any OpenShift subscription, meaning that when you purchase OpenShift virtualization is part of that. And the way you can install it is you can go to the operator hub and you search for OpenShift virtualization, and you can find the OpenShift virtualization operator out there, and you would install it just like how you would do any containerized application. So, and then once you have that, your existing virtual machines can be migrated from any other platform. I mean, this could be like VMware, Red Hat Virtualization, or even OpenStack for that matter. And we have tools for that. And these are free tools, very intuitive tools where you can just use those tools to migrate from those platforms onto OpenShift Virtualization. And after that, the resulting VMs will run alongside the containers on the same Red Hat OpenShift nodes. So basically with OpenShift Virtualization, you have added some new objects to your Kubernetes or OpenShift cluster. And what I mean by that is now customers can now have do things like creating new VMs. It means managing VMs, and these are all like I'm talking about not just Linux VMs but also Windows VMs can now be created and managed using OpenShift Virtualization. You get a set of new CLI tools and UIs to control and manage your virtual machines. One of the main things we see is live migration, which is key to customers using virtual machines. You could do that with OpenShift Virtualization. Let me move on to the next slide, and I'll talk a little bit more on how some of these things can be done. So one thing I want to call out before this is that when you are using OpenShift Virtualization, your VM would be running on a worker node or a compute node in the context of OpenShift. That compute node needs to be a physical machine. So what I mean by that is if you are on the cloud, for that matter, your other worker nodes can be EC2 instances, but the machine on which your virtual machine runs has to be a bare metal node, and that node has to be, you can create a machine pool and add those so that your virtual machines can run on those three nodes where OpenShift Virtualization is running. So just wanted to call it out before we move forward. Next slide, please. So now I'm going to talk about what ROSA is and how OpenShift Virtualization comes into ROSA. So ROSA is nothing but managed OpenShift on AWS. So like I said, OpenShift by itself is a turnkey application platform, but now you're getting it on AWS and it's available on AWS console and it's managed for you by Red Hat SREs. So what that means is that the Red Hat SREs will take care of the day one, day two operations, and they also provide a 99.95 financially backed SLA. Now, because ROSA is nothing but managed OpenShift, it's also turnkey with all the services and tools that you've been using with OpenShift in the past. So it's the exact same thing, but the focus is to bring down your time to market. So meaning with OpenShift, your time to market or taking your service to your end customers has now been reduced. So this particular slide which you're seeing it's been jointly created by Red Hat and AWS. So what you see is under containers on the AWS console, you'll see ROSA, but you also see EKS and ECS, and each solving different use cases. As you can see, there's a box in the slide which says build your own application platform, and this box you can see a number of services, and these are all AWS services. So if you want to build your own application platform, what you would need to do is you need to take all these services which AWS offers. You have to piece them together, put them together, configure it, make sure they're running fine together, and then you have your application platform to run your services, right? But think about this, at the same time, AWS offers ROSA, which is a turnkey platform. So all these services like the CI/CD pipeline, the registry, anything that you need to run a production Kubernetes cluster is all there for you. That way, reducing your time to take your service to the market. So if you have all the time and bandwidth, you can piece them all together on AWS. But if time to get your service in front of your customers is important, then you have a turnkey solution available in the form of ROSA on AWS. Next slide, please. So at this point, there's a key piece, which is storage, which is necessary for ROSA. And I'll let Bhavin talk about how Portworx and OpenShift Virtualization work together and provide value to the end customers.
Thank you, Mayur. Okay, so Mayur covered the compute pieces and all the CI/CD pipeline pieces, but how can Portworx help, right? How can we provide that Kubernetes or OpenShift data management platform that allows you to run your containerized applications, if you have them, and your virtual machine-based applications side by side on the same infrastructure stack? So before we talk about all the features that Portworx brings to the table, I wanted to just do a high-level introduction for people that are not familiar with Portworx yet. So Portworx has been recognized as the #1 Kubernetes data platform or container data platform for the past 5 years running, or 4 years running, I think at this point. It provides you with a cloud-native storage solution that allows you to run any application. So this can be any containerized application, any virtual machine-based application, any database solution, or basically any stateful application that needs access to storage on any Kubernetes solution, in this case, any Red Hat OpenShift cluster. As Mayur mentioned, you can run Red Hat OpenShift on-prem, on bare metal nodes, on virtual machines, or you can run them in the cloud with a service like Red Hat OpenShift service on AWS or ROSA. So Portworx allows you to run any app on any infrastructure, basically at any of these environments, including on-prem to public cloud to the edge. So, but Portworx is a portfolio of products, right? So what does the portfolio include? The first thing is something called Portworx Enterprise. This is the cloud-native storage layer that is responsible for dynamically provisioning block and file-based volumes that are needed by your virtual machine application. So if your virtual machine needs a block storage device attached to at specific locations, you can do that using Portworx. Or if you want multiple virtual machines to have access to the same NFS share, you can do that using Portworx as well. So Portworx brings that unified storage layer for all kinds of needs from your applications. Because Portworx is completely cloud native, let's take the example of on-prem OpenShift cluster where you're running it on bare metal nodes that are spread across different racks inside your data center, right? With Portworx, we have the intelligence built in that if you tag the OpenShift worker nodes appropriately, we'll make sure that your volumes, your primary copy of your volumes, are distributed or are replicated across different failure domains or different racks inside your data center. So even if you lose power to one specific rack in your data center, you can still have access to all your applications, all your data without having to worry about failing things over to a different rack or a different worker node. So Portworx provides a native high availability. Talking about performance, with our latest storage architecture, if you're running this on-prem on bare metal nodes with NVMe drives, you can actually get more than 1 million IOPS per Kubernetes worker node as well. So Portworx does provide you with that high performance that you need for certain applications, like, for example, Elasticsearch running on Kubernetes or OpenShift. We also provide you with thinly provisioned storage. So let's say you have thousands of developers to support, and we all know developers at this point. If you have worked with them, they don't exactly know what they need. They'll just ask for random resources. Give me a virtual machine that's 4 vCPU, 8 gigs in RAM, and maybe give me half a terabyte of storage, even though they only need like 50 gigs right now. So with Portworx, you can actually thin provision storage. So when developers are deploying these virtual machine objects on a self-service basis, Portworx makes sure that you're not allocating or thickly provisioning storage and using up your underlying storage that's available to all your tenants or all your developers. So you get these same features that we spoke about across cloud environments, across on-prem environments as well. So that's that consistency because we are completely cloud native. As an administrator or as a platform admin responsible for providing services to developers, you can use Portworx Enterprise to create different classes of service as well. So let's say your developers need access to storage for their test dev applications. You can have a test dev or a bronze tier of storage, which doesn't really do any replication, doesn't really put all workloads in NVMe devices. If you have access to different types of media, you can map it to a slower medium as well with no replication, and you can create these different classes of service based on the type of applications or workloads that you want to run on top of your OpenShift cluster. Next, we also have our business continuity and disaster recovery solution. So virtualization admins are very familiar with tools like VMware Site Recovery Manager or data protection solutions like Veeam or Commvault. When you modernize your infrastructure stack, you also need modern solutions. And you know that the need for having a DR solution or a data protection solution doesn't go away. Portworx has an answer for that. Portworx provides you with a data protection solution that can help you protect not just your containers, which is what it was built for, but also your virtual machine objects that are running on OpenShift. And with disaster recovery, that's one of the demos that we look at today. You can actually build a synchronous DR solution where you can fail over your applications between your primary and your secondary cluster without any data loss. You can, if you wanted to build like a cross-region architecture or a hybrid cloud architecture, you can also build these async DR solutions where your primary site might be running on-prem, your secondary site is running in the cloud, and every 15 minutes we are taking whatever has changed in the last 15 minutes and pushing it to the cloud, always making sure that you can recover almost instantaneously in case something happens to your primary data center on-prem. So talking about OpenShift virtualization specifically, I want to talk about like virtual VM migration, right? So there is a tool called Red Hat Migration Toolkit that allows you to move your virtual machines from your traditional virtualization stack to this modern virtualization stack. But once it's running on the modern virtualization stack, you still need access to features like live migration or vMotion or the ability to recover your applications. So like traditional vSphere HA, you still need access to all of those features. This is where Portworx can help. If you have a cross-rack or a cross-availability zone OpenShift cluster, you can actually live migrate your virtual machine objects between different failure domains on-prem or in the cloud. We already spoke about the benefits of having that unified storage layer or that common storage layer for your virtual machines and your containerized applications. But talking a bit more about a feature that I really like, and this is something that we look at in the demo as well, is something called Portworx Autopilot. So we all know that if your virtual machine, or even for that matter, your container runs out of space, that application component goes offline, which creates downtime, which you don't want. Usually in traditional virtualization, there are monitoring tools that administrators use to monitor and then always have buffer capacity. So like as soon as something reaches 80% capacity, the administrator will manually go ahead and expand the virtual disk or vdisk and make sure that the application never runs out of storage. What Portworx has done is we have automated all of this, right? So you, as administrators, you can just have policies in place. And once Portworx observes that a specific virtual machine disk is exceeding that threshold that the administrator has set for it in that policy, we'll perform an expansion operation on that virtual machine without any downtime. So it allows operators or administrators to focus less on the day-to-day management of virtual machines and the storage, but work more closely with their application teams. And then we already spoke about disaster recovery and business continuity. Synchronous and asynchronous disaster recovery needs or requirements don't go away just because you're running your applications on a modern stack, right? You still need to find an answer of how you'll implement zero RPO, synchronous DR, or async DR for your applications running in production. So with that, we have a couple of animated slides before we jump into the demonstration. So we spoke about how Portworx does things on-prem across racks, right? Let's look at ROSA, or Red Hat OpenShift Service on AWS, and see how your applications are actually being deployed. So let's say you have a cross-availability zone ROSA cluster running in a specific AWS region. Whenever you deploy a virtual machine that needs access to storage, Portworx will provision that storage in the same availability zone that your virtual machine object exists in, but we'll make sure that we spread the replica of that persistent volume or that storage resource across different availability zones. So this will depend on the policy or the class of service that has been defined by the administrator. The administrator says replication factor of 2. We'll make sure that there is a primary copy and there's a secondary copy. If the admin says replication factor of 3, we'll make sure that there is a replica available in all 3 AZs. So if anything happens, or if you want to migrate your virtual machines from AZ1 to AZ3, you can actually just go to the UI, click one button, and we'll move your virtual machine and make sure it has access to data locally inside that availability zone. Talking about the next important thing, which is high availability. So what happens when a node goes down or an availability zone goes down? In traditional virtualization, like I used to be a VMware admin, if you lose a node that has VMs running on it, vSphere or vCenter will make sure that it restarts the same virtual machines on a different node in your cluster. What happens when you're using a modern stack, right? If you lose an AZ or a failure domain, you can still trust us that we'll restart the virtual machine on a different or a surviving node in your cluster and make sure, because of the replication that's handled at the storage layer, you will have access to all of your data. So that's how high availability is handled inside OpenShift Virtualization and Portworx. And then talking about asynchronous DR, you can have this hybrid cloud architecture where you have an OpenShift cluster running on-prem. You're using a ROSA cluster as that secondary site. And every 15 minutes or an SLA that you tell us to follow, we'll copy things from our primary cluster to the secondary cluster and have it ready to be in a recoverable state. What does this mean, right? So we'll always have the latest copy of your data in that 15-minute window. And then we'll have all the different resources. So the way to, if you are deploying virtual machines, you can use OpenShift routes and ingress objects. All of those extra resources that you might be running as virtual machines today can be protected and be ready to be recovered on your secondary site as well. So if in any case, or in a case of disaster at your primary site, you can log into your secondary cluster, bring your virtual machine objects online in a matter of seconds to minutes, because we already have the metadata, we already have the data. All we need to do when you activate that disaster event or tell us it's a disaster event is turn on the virtual machine object. So the time it takes to turn on the VM is the time it takes for you to bring your applications back. If you are doing this across two synchronous clusters, your data is always replicated. So like even before the write is acknowledged back to the application layer, we'll make sure that it's copied to the secondary site. So in case anything happens with your primary OpenShift cluster, you have access to all of your data and you can bring your applications or turn them on almost instantaneously on your secondary site without any data loss. So that's how async DR and sync DR works with OpenShift Virtualization and Portworx. So we have had a lot of slides. Let's look at a couple of demos that we have. In the first demo, what we are going to show you is the live migration, the high availability, and the automated storage capacity management in action. So we have our ROSA cluster that's deployed here. And we'll start by deploying a simple virtual machine. So this is just to show you how easy it is, right? So if you're using traditional virtualization right now, you're used to using a vCenter interface, or if you're using Nutanix, you're used to using Prism or Prism Central, you can still navigate to a UI and access the virtual machines tab and start deploying virtual machines on your OpenShift cluster. OpenShift Virtualization also comes with a template store and a catalog where administrators can have golden images that are available for anybody to deploy. So you can go ahead and select a CentOS 7 template. You can customize the virtual machine completely, give it your own name. You can select what kind of storage you want, whether you want read write once, read write many, how much storage you want. You can configure all of those things. OpenShift Virtualization based VMs have cloud init functionality as well. So you can add additional scripts that you want that can be executed at boot up time. You can also edit disks and change its storage classes, change the amount of capacity, and the access type as well. All the operations that we're doing right now through the user interface can completely be automated using a simple YAML file, right? So developers don't have to learn about how to access OpenShift web console. They can do everything from their YAML files or their command line interfaces itself. So as you can see, once you clone from a template, it creates a new persistent volume object that's backed by Portworx and creates that virtual machine object that will run your CentOS 7 instance. But now let's try to access the virtual machine. And then what we'll do is, with the integrations that Portworx has built inside the OpenShift web console, we'll look at how storage is actually spread across for this VM. So we were able to log in using the password that you set during virtual machine creation. Now let's look at the OpenShift dynamic console plugin that Portworx has built, which gives you more details about how the volume and its replicas are spread across different OpenShift worker nodes. So we'll select the MongoDB virtual machine that we just created. We'll select the Portworx tab inside the UI. And then in this tab, right, you can find more details about the replication factor. So it depends on the class of service that you selected. It shows you which nodes are actually hosting a replica. So if this was a simple 3-node cluster spread across 3 AZs, which made sure that all of my replicas were available in different availability zones. But even if you have more nodes, we'll automatically schedule it across different AZs. We also show you the virtual machine object that's associated or writing data to this specific persistent volume, and show you the format as well. So that's a simple way of getting more details about the virtual machine disk itself. Next, we already saw this animation in the slides, but let's look at how easy it is to live migrate a virtual machine between two different availability zones inside an AWS region. So, okay. From an animation perspective, AZ1 to AZ3 seems simple enough. Let's see how complicated it is when you actually have to do it through the OpenShift web console. So we'll access the VM. You just have to click on the 3 dots on the right, and then you hit migrate. This will initiate a live migration operation, and that's how easy it is. You don't have to worry about doing anything else. Just hit migrate, and we'll migrate it to the best available node that's available in your OpenShift cluster. So it goes from, it never shuts down the virtual machine. It's a live migration, so you don't lose access to your VM. You don't even lose access to the session that you might have running in your virtual machine. And let's verify that by trying to access the virtual machine console. If you look at the VM console, my last session that we logged in after deployment is still online. So this was indeed a live migration operations. If this was actually running a MongoDB instance, you would never have seen any interruption to the application IO. So that's one thing, right? That's a live migration. Next up in this demo, we'll show you the high availability and how, if something happens to an OpenShift worker node or an AWS availability zone, how do we handle that failure event? So again, we saw this animation. If AC2 goes down, how can you recover everything to AC3 without any user or admin interference? Let's go ahead and simulate a failure event, right? So we identify the node that your virtual machine is running on. So 179.104, that's the IP address or the node name for my OpenShift worker node. And since this is a ROSA cluster that's running on AWS, it will have an EC2 instance that's backing it. So let's find out the exact node with the same IP address from our worker nodes, our metal instances. And once we find that, we can just turn off this worker node, right? Which basically simulates the fact that, okay, this worker node or this availability zone is going offline. So once we find that instance, verify that it's the right one, we'll click instance state and basically reboot the instance. And this will force any applications that are running on top of that worker node to basically reboot or restart on a different node in your cluster. So once that is, once the node has been successfully rebooted, we can go back to our OpenShift web console, and you can see that our VM goes from a running state. It does go through a reboot, and you can observe that the node changes from 179.104 to whatever the new node for that's selected as the best place to run this virtual machine is. So as you can see, our VM has been migrated to, instead of 179, it's now a 192.11 worker node. And if we try to access the VM console, you will see that since it rebooted, we lost our session, but then we were still able to access our virtual machine object and resume our application. So an AZ going down, right? That's a big event, or a failure domain going down. The administrator didn't have to worry about recovering from backups or finding the right backup jobs to snapshots to recover from. Because of the way Portworx does replication at the storage layer, and because of the way OpenShift virtualization works, your VM was automatically rebooted on a different node and brought online. And once it's back, your application can start read and write operations as well. So that's how high availability is handled. Let me skip forward, and we can talk about how we do automated storage capacity management. So automated storage capacity management is delivered through a functionality called Portworx Autopilot. And it's a simple rule that administrators can set. So in this case, since this is a demo, I want my Postgres application, if it exceeds 10% of utilization on its virtual machine disk, I'll add 20% more capacity to that same virtual machine disk. So I'm keeping that threshold to 10% because this is just a demo, but in real life, you can set it to 75%, 80%. And whenever the threshold is exceeded, Portworx will automatically expand based on the scale percentage that you have provided us. And then it will keep doing this till it hits a maximum size. So you don't have to worry about runaway costs, right? You can have a max limit that Again, you can modify if you wanted to, but it will perform this automated operation till it hits that limit. So our virtual machine right now is 11 gigs in size, the Postgres VM data disk. We'll go ahead and apply the autopilot rule, and then we'll access, once the autopilot rule is created on our OpenShift cluster, we'll go ahead and access the console for our Postgres VM and start generating random IO against our virtual machine. So let's start a watch event to make sure that we are catching all the events. So autopilot goes through a series of transitions, right? Once you deploy it, it's in the initializing state, and then it sits in the normal state till it is actually being triggered. Once it's triggered, it goes from trigger to active actions pending because it knows it has to do something. From there, it goes to active actions taken. Active actions in progress, which means that it's doing something, and then active actions taken is the final state, and then it goes back to normal again. So let's go ahead and access the console for our Postgres VM. Again, this is the VM that has that Postgres VM disk associated with it. And then we just need to start a simple FIO job that will start writing 5 gigs of data against our 11 gigs of persistent volume. So 5 gigs is definitely more than 10%. So as soon as it crosses that threshold, you will see new events being generated where we are expanding that volume disk. So as you can see, since this is a recorded demo, I can fast forward things and not have to wait for it to write 5 gigs worth of data. But the rule that was configured goes from normal state to a triggered state. And then from triggered, it goes to active actions pending. Again, this is completely automated, right? The administrator didn't have to log into the cluster and expand disks manually. All of these operations were done automatically because of policy being set on day 0. So my 11 gig persistent volume expanded to like 14 gigs because I wanted to increase its size by 20%. And my VM never went down. My application continued writing data. If I go ahead and access the console, you will see that my FIO job never failed because it never ran out of storage. So that's one portion of the demo. I know we are running low on time, but let me do one more where we talk about how Portworx provides disaster recovery. Again, if there are any questions, feel free to put them on the Q&A window, and we can answer them after we're done with the demos as well. So in this demo, what we have is a mixed application. What do I mean by a mixed application? Our backend database, my MongoDB database that's responsible for the persistence layer of this application, is running on a virtual machine object, but my front-end components, the UI components, are actually modernized and are running as containers. So if you are in a similar situation, how can you protect this mixed application using Portworx Enterprise and the disaster recovery capabilities that we bring to the table? That's what we look at in this demo, right? So we have a simple barbecue-based demo application that one of my teammates has built just for purposes like this. And we are running the front-end components as containers, back-end components as virtual machines, and we're going to leverage Portworx running on OpenShift to protect those. So let's go ahead and generate some data inside our barbecue application. If you are hungry, don't blame me, blame Eric Shanks, I guess. We'll basically go ahead and log in as a demo user that we have pre-created, demo@portworx.com. Don't try to send any emails to that. That's a dummy email. Doesn't really exist. And once you log in, you can select from what you want to order from the available menu options. So we'll select some chicken, and then you can select a couple of side dishes. Again, all of these entries and entities are basically stored in the backend MongoDB database collection. So they are persisted across reboots and things like that. Once you are done placing one order, you can look at the order history. You can see I've placed a few more orders in the past that I'm waiting to be delivered. So I have my orders placed. Let's go to the CLI and access our application, or look at what our different application components look like. So as you see, we have a few pods that represent our front-end components. We have a few service objects. If you do a get virtual machines, you will see a virtual machine object, which is responsible for running our MongoDB instance. And if you look at a persistent volume, you can also see the persistent volume is actually backed by Portworx that's responsible for storing your MongoDB information. So it's a 33 gig volume that's supported by Portworx in redirect menu mode. Once all of this is done, we looked at the menus or the order history from the UI. Let's actually log into our backend virtual machine, which is running MongoDB, and use MongoSH to figure out what the orders history looks like inside that database a collection. So once we switch to the right collection and authenticate against it, you can see we'll do a list on the collection and look at all the 3 orders that we just placed or we have in our order history. Super secure password, Portworx Bank, and then just the username is my user admin. Once that's done, we'll do a list. And then these are the same orders that we saw from the UI, right? So this is our company's data that we want to protect from any disaster event. This is where Portworx disaster recovery solution comes in. So we'll create a new migration schedule object. So since this is synchronous DR, my data is always replicated to the secondary side once we deploy that migration schedule. And then at frequent intervals that you configure, we'll copy all the Kubernetes or OpenShift resources like containers, service objects, config maps, or secrets that you might have, and make sure they are ready to go on the secondary site as well. So a simple migration schedule custom object, custom resource definitions looks something like this. You specify the namespace where your application is running in. You select the cluster pair object, which is something that is like a pre-step to doing this. Cluster pair is basically a trust relationship between primary and secondary cluster. And then you tell us like whether you want to include all resources, whether you want to include volumes. Volumes is set to false because this is sync DR, and we'll handle that replication at the storage layer. And then we'll follow the demo policy as the schedule policy for everything remaining in your namespace inside OpenShift. If we log into our secondary cluster, you'll see that it's a similar OpenShift cluster running version 125. I think it was running OpenShift version 4.11. This is our secondary site, right? We look at our same namespace, app-demo. You can see we don't have any resources running right now because we haven't officially kicked off the DR task. We don't have any persistent volumes that are ready to go. So now let's go ahead and apply this MIG schedule migration schedule object against our primary site. And then once the first migration happens, you will start seeing objects popping up on the secondary side, because again, it's not active, but it's active and ready to be active configuration between our primary and our secondary cluster. So first migration has been successfully completed. So now we can look at more details about the migration object themselves. So it shows you that it copied 10 different Kubernetes objects or OpenShift resources, 0 volumes because we handled that replication at the storage layer. So our migration first instance is good to go. So this will keep happening for every time we hit the schedule policy, so the amount of time that you want us to follow. And then let's look at what the resources look like on the secondary side. So if you do a get all, you will see that you have your service objects, your deployment objects with the replica count set to 0. You will have your OpenShift routes and your virtual machine in a stopped state. Again, the pods, you don't see any pods, and you see the virtual machine in a stopped state because this is not active. We don't want to create inconsistency in your application layer by having 2 replicas of the same VM running on 2 different OpenShift clusters. But you see that you already have your persistent volume ready to go on your secondary side. And any changes happening on the primary side will be replicated on the secondary side. Now let's go ahead and simulate a disaster event, right? I think that's the theme for this webinar. We try to turn things off or shut down entire OpenShift clusters to prove the value that Portworx brings to the table. Once we deactivate the cluster domain, we look at the status, and you'll clearly see that what used to be in sync between our primary and our secondary cluster will quickly go out of sync as soon as we deactivate the cluster domain. Next, we scale down the front-end components, so the pods that we had. Since this is a simulation, we have to follow these steps. In case of an actual disaster event, you will lose access to your primary cluster anyways. You won't be able to do any of this, and you just have to move on to the recovery side of things. So we'll go ahead and scale down our front-end components. We log into our OpenShift web console and turn off our virtual machine on the primary side, basically turning everything down on the primary cluster. And then we'll navigate to our secondary cluster CLI session and activate our DR plan so that our application can be restored. So the virtual machine, once it's stopped, we'll proceed with the recovery. Hope everybody is able to keep track of what we're doing here. Again, if you have any questions, feel free to put them on the Q&A section. Okay. From the UI, it looks good. Let's verify it from the CLI once again. And you can see our what machine pod is in terminating state. Our virtual machine is still in the stopping state. Once that's done, let's go back to our secondary site or secondary cluster. And then this is what you need to do to recover your applications, right? No need to panic. All you need to do is just one simple command. Startctl activate migrations, and then you specify the name of the namespace where your application is actually running. Once you give us this command, we know that there has been a disaster event and we need to recover your application, which means from looking at our metadata and figuring out how many pods you had running originally, and we'll spin up the number of pods. And then finally, we'll also start your virtual machine object so we can bring your application back online. So once I'll skip ahead because we are running low on time, but your virtual machines will be powered back on. Your persistent volume already existed. And one last thing that we need to do is update your load balancer endpoint. So like update your route endpoint. So instead of pointing it to the original cluster, we'll point it to the new cluster. And once that's done, you can go ahead and access your barbecue application using the new route endpoint or your load balancer endpoint. And once we do that, we can log in using demo@portworx.com and the same password, and then go to our order history and validate that all our barbecue orders are still intact. So this is how Portworx can help you build a DR stack for mixed applications as well. So mix of containers and virtual machine based applications. We can also do just containers. We can also do just virtual machine, but this was a cool demo that we wanted to show you. Let me go back to our slides. We have a QR code that you can scan if you want to get more information.
Thanks for having us.
Okay, everyone. Thank you so much, Bhavin and Mayu, for putting together that fantastic presentation. I learned a lot. One of the things I wish I hadn't learned is that using a barbecue website is not a great idea for those of us for whom it is lunchtime right now, because I'm very hungry after seeing that demo. But oh well, I'll survive until after this. So thanks again. I did want to mention that we are now out of time, and we're not going to be able to get to the Q&A because we're going to have to cut you folks loose here in just a minute. But I do want to mention that Portworx and Red Hat will be following up on any and all questions that were asked. So have no fear if you asked a question. They will be getting back to you with that information. So we're just about done here, everyone. Before we wrap up, I do need to give away a gift card. As I mentioned at the beginning, you have to be present for the entire event to be eligible. And the winner of the $250 Amazon gift card for this event is Susan Shao from California. Congratulations to you, Susan. We will be in touch with you ASAP to get you your card. And with that, everyone, we're wrapped here today. On behalf of the Actual Tech Media team, I want to thank Portworx and Red Hat for making this event possible. And for you attendees, I want to thank you so much for being here, for spending part of your day with us, for your great questions and your interest in this topic. I learned a lot, and I hope you did too. And I look forward to seeing you in the next one. So that concludes today's event, everyone. Have a great rest of your day.